You know, everything you see, everything you can touch, even you, it's all made of atoms. But what if I told you that when you zoom in on those atoms, the world you find is, well, it's way stranger and more fascinating than you could ever imagine. And our whole journey into that world starts with a really simple but kind of mind-blowing paradox. Right? I mean, this question just completely messes with our heads. You feel solid. The floor you're standing on feels solid. So if it's all supposed to be empty space, what is actually going on here? And look, we're not talking about just a little bit of empty space. We're talking almost all of it. Get this. If you blew an atom up to the size of a melon, its nucleus would still be too tiny for you to even see. The rest? Just nothing. A huge, empty void. Okay, so let's dive into this and unpack this whole illusion of solidness. Because the feeling of solid has nothing to do with stuff being packed together tightly. Nope. It all comes down to some really strange and powerful rules that control all that emptiness. So to get this, we've got to update the picture of an atom we all have in our heads. You probably remember that old solar system model from school, right? With the little electron planet zipping around a nucleus sun? Well, the reality is so much weirder. Electrons don't really orbit at all. They exist in this fuzzy cloud of probability. And this analogy is just perfect. Think about it. You can't point to one specific bee in that swarm, can you? But the swarm itself, it has a definite shape, a boundary. And that electron cloud, that's the atom's first line of defense. Okay, so if it's not actual stuff making things solid, then what is it? Well, it's forces. That vast, empty space inside an atom isn't just chaos. It's run by some of the most basic, fundamental rules in the entire universe. And here it is, the absolute star of the show, the Pauli exclusion principle. Now, I know it sounds super complicated, but the main idea is actually surprisingly simple, and it's the #1 reason your hand doesn't just phase right through your desk. This is such a fantastic way to picture it. It's like every electron has its own signature dance move, and when the electron clouds from your hand get close to the electron clouds in the floor, they can't do the same dance steps in the same spot. The rulebook says, nope, not allowed. And this leads to a pretty mind-bending conclusion. You have never, ever actually touched anything in your entire life. Seriously, what you feel as touch is just the electromagnetic force of trillions of electron clouds pushing back against the ones in your hand, refusing to let them pass. Solidity isn't a substance, it's a force field. Okay, but hold on a second. This brings up a whole new paradox, doesn't it? If the big rule is stay away from each other, then why isn't the whole universe just a big, lonely cloud of atoms all pushing each other away? I mean, how do molecules or planets or us even exist? Well, it turns out that even though atoms really value their personal space, they also have this deep, deep drive to connect with each other. They just need to find the right way to do it. And it all comes down to one of the most basic rules in all of science. Everything in nature wants to be in the state of lowest possible energy. It's just like a ball rolling down a hill. It's always going to end up at the bottom, where it's most stable. This chart shows it perfectly. See? When you have two separate atoms, they're buzzing around with a lot of energy. They're at the top of that energy hill. But when they link up and form a bond, boom, they drop down to that much lower, more stable energy state. It's just cozier for them to be together in a molecule. And the whole process is this kind of elegant dance. First, two atoms get close to each other. Then, they find that perfect little sweet spot, just the right distance where the pull to come together is stronger than the push to stay apart. Then, they share some of their electrons. And just like that, a stable, low-energy bond is formed. And the results of this one simple drive, they are absolutely staggering. This basic need for atoms to get comfortable and find their lowest energy state, that's what gives us water. It's what gives us the air we breathe. It's what built the incredibly complex DNA that makes you, you. So, okay, we figured out why the world feels solid and we figured out why it all holds together, but there's one last really profound idea I want to get into. What happens to all those atoms, the atoms that make up you, after you're gone? Well, there's another one of those fundamental laws of the universe, and it basically says that this stuff, this matter, it can't be created or destroyed. The atoms you're made of have been around for billions of years, and they'll be around for billions more. They just get rearranged. So think about what that means. For your atoms, death isn't the end. It's just a new beginning. They get released from this temporary arrangement we call you, and they go back into the great cosmic recycling bin. It's this incredible, grand cycle. Your atoms might become nutrients in the soil. They could evaporate into the clouds and become rain. They get released into the air as gases, then absorbed by a plant, which then gets eaten by an animal, and eventually they get rebuilt into something new. New animals, new people, new life. You're literally borrowing atoms that were once part of who knows what else. But for a very, very small number of your atoms, the journey is even more epic. See, because of a little bit of natural radioactive decay that happens in all of our bodies, some of your atoms are destined for something else entirely. Let's follow a single helium atom, for example. It's super, super light, so light that once it's released, Earth's gravity just can't hang on to it. So it starts to drift up and up, right out of our atmosphere and into space. And from there, who knows? It could travel for millions, even billions of years. A tiny, silent piece of you exploring the cosmos. So when you put it all together, you get this amazing takeaway. You aren't just a temporary person. You are a temporary arrangement of ancient stardust. Just let that sink in for a second. The very atoms that make you, the carbon in your skin, the oxygen in your lungs, the iron in your blood, every single one was forged inside a star that exploded billions of years ago, long before our own sun even existed. You are literally a walking, talking piece of cosmic history. So these ancient atoms are on an endless journey, and they're just passing through you for a little while. Their story doesn't end here, which leaves us with one final, incredible question to think about. What will your atoms build next?